Good morning, students. Yesterday we have discussed the reduction formula of integral 0 to pi by 2 sin power nx dx and integral 0 to pi by 2 cos power nx dx. So this is what we have discussed yesterday. Integral 0 to pi by 2 sin power nx dx and that of integral 0 to pi by 2 cos power nx dx. For both of them, results yielded the same. So if n is even, then n minus 1 by n, this is the first term. So you go on writing the successive factors reducing by 2 both on the numerator as well as the denominator until we reach to either 2 or 1. So in this way, if I got 1 by 2, then into pi by 2 we have to end up. And the same case, n minus 1 by n, n minus 3 by n minus 2, very first n minus 1 by n. So you go on writing the successive factors reducing by 2 both on the numerator as well as denominator, and in this way if I ended with 2 by 3, the next factor is into 1 if n is odd. This is what we have learnt yesterday. So we will be learning integral 0 to pi by 2 sin power mx into cos power nx dx. Remember, this is the special reduction formula. The integrand contains sine and cos functions with their powers, and strictly speaking the lower limit is 0 and the upper limit is pi by 2. So it is not 0 to 2 pi or 0 to pi something else. So it is strictly between 0 to pi by 2, because this is a special case which we will be discussing now. See, integral 0 to pi by 2 sin power mx into cos power nx dx. So let us take this to be I m comma n is equals to this. This is equals to 0 to pi by 2. We are free to choose. We are free to choose or split cos power nx or sin power nx dx. So in both the ways we can get the reduction formula. Of course, the reduction formula will be differed with these two, but ultimately if you substitute the limit 0 to pi by 2, then the definite integral will be the same. So what I mean to say is, it can be done in sin power mx can be split as m minus 1 x into sin x, leaving cos power nx dx intact. So in this way, if you proceed, we will be getting one reduction formula. So otherwise, leaving sin power mx dx intact, so I am splitting cos power nx dx as cos power n minus 1x into cos x dx. So you are free to choose any one of them. So let us proceed with this. So here I'll take this to be the first function f of x and the remaining as g of x dx. So we know how to do this using the integration by parts. Integral of f of x into g of x dx. First function into integral of second function dx, a to b, minus integral of a to b d by dx of first function into integral of second function dx whole dx. This is how we will do. So the same way, so the first function is cos power n minus 1x into sin power mx into cos x dx. So 0 to pi by 2 will be written here, minus 0 to pi by 2 d by dx of cos power n minus 1x into integral sin power mx into cos x dx whole dx. Okay, so now cos power n minus 1x sin power mx into cos x dx. See here, we have a formula. See, sin x, if I take it as f of x, then if f dash x is cos x. We have a formula which we have discussed in the results of the integrations chapter, indifferent integrations chapter. What is that? F of x whole power n into f dash x dx. F of x whole power n plus 1 by n plus 1. So this is sin power m plus 1x by n plus 1. So the process of integration is over. So 0 to pi by 2 is to be written here. Minus integral of 0 to pi by 2 d by dx of cos power n minus 1x. This is to be treated as cos x whole power n minus 1. Cos x whole power n minus 1. So d by dx of cos x whole power n minus 1 we don't know. So let us take cos x to be x. Then x power n is n into x power n minus 1. So this will be n minus 1 into x is cos x. So cos power n minus 1 minus 1 n minus 2x into, again I am telling you, this is cos x whole power n minus 1. Cos x is to be treated as x. X power n minus 1 x power n minus 2 into, since cos x is to be taken as x, we need to differentiate it later. So d by dx of cos x is minus sin x into integral sin power mx into cos x dx. We have already written here. What is that? Sin power m plus 1x by m plus 1 dx. So this is f of x whole power m into f dash x. F of x whole power m plus 1 by m plus 1. So this dx is as usual. This is equals to, now you substitute upper limit. Since there is no integration here, therefore we will be applying the upper limits and lower limits. So cos power n minus 1 x is the upper limit pi by 2. Cos 90 is 0. 0 into something as a whole, this is 0. Minus lower limit, cos n minus 1 into 0 is cos 0. 1 whole power n minus 1 is, this is of course 1, but sin power m plus 1 x if you substitute here. So sin 0 is 0 power m plus 1 is 0 into something, this is 0. What I simply wanted to say is upper limit minus lower limit is simply this as a whole 0. Okay, and minus into minus is plus. N minus 1 is a constant by m plus 1 is a constant. I am separating this as well as this from the process of integrations. Integral 0 to pi by 2 cos power n minus 2x. So this is sin power 1x. Bases are equal, exponents are to be added. That means sin power m plus 1 plus 1 m plus 2 x dx. This is equals to n minus 1 by m plus 1 0 to pi by 2 cos power n minus 2x into this sin power m plus 2x can be written as sin square x into sin power mx dx, because this is a power m plus 2, a power m into a power n, a power, okay, this into dx. This is equals to n minus 1 by m plus 1 integral 0 to pi by 2. See this, cos power n minus 2x, sin square x is 1 minus cos square x into sin power mx dx whole dx. This dx is not there, so this, because this as a whole dx is the integration we have already written here. This dx is getting followed. Now n minus 1 by m plus 1 into integral 0 to pi by 2 cos power n minus 2x into 1 into sin power mx. So as a whole this is sin power mx into cos power n minus 2x minus, this is cos power n minus 2x into cos square x, n minus 2 plus 2, so n cos power nx into sin power mx. So this is sin power mx into cos power nx dx, nx whole dx. Let us continue. So this is n minus 1 by m plus 1 integral 0 to pi by 2 sin power mx into cos power n minus 2x dx minus n minus 1 by m plus 1 integral 0 to pi by 2 sin power mx into cos power nx dx. What is all this? Imn. So this is equals to n minus 1 by m plus 1 if integral 0 to pi by 2 sin power mx into cos power nx dx is to be treated as Imn. In the same way, integral 0 to pi by 2 sin power mx cos power n minus 2x dx can be treated as Im comma n minus 2 like this minus n minus 1 by m plus 1 integral 0 to pi by 2 sin power mx into cos power nx dx, which we have taken this is Imn earlier. So may I replace this with Imn? So this is equals to Imn. This minus term if you bring here will be n minus 1 by m plus 1 Imn is equals to n minus 1 by m plus 1 Im comma n minus 2. This is equals to Imn if you take it as a common, so 1 plus n minus 1 by m plus 1 is equals to n minus 1 by m plus 1 Im comma n minus 2. So this implies Imn LCM if you find m plus 1 plus n minus 1 by m plus 1 is equals to n minus 1 by m plus 1 Im comma n minus 2. This m plus 1 gets cancelled. So therefore Im comma n is equals to n minus 1 by this 1 gets cancelled, this m plus n is getting multiplied. So if you bring here, if you transpose here, it will be dividing. So m plus n Im comma n minus 2. So this, if you continue this process, this successive reduction process, m comma n is 1 less than this n and the sum of them and same m n minus 2. If you proceed, is equals to n minus 1 by m plus n into Im minus 2 is n minus 3 by m plus n minus 2 into Im comma n minus 4. If you further reduce or if you further apply the successive reduction, we will be getting n minus 1 by m plus n into n minus 3 by m plus n minus 2 into this im n minus 4 is n minus 5 by m plus n minus 4 im comma n minus 6, and this process goes until we will get the final answer, the final term, either I1 or I0 depending whether n is odd or n is even. Proceeding like this, we obtain n minus 1 by m plus n into n minus 3 by m plus n minus 2, etc. Im comma 0 or Im comma 1 according as n is even or n is odd. So if n is n is odd, and remember these are all m comma n which are greater than or equals to 2. So this result, this reduction formula is valid as long as m comma n are the positive integers greater than or equals to 2. Since if n is odd, so we will be end up with this. So that is integral 0 to pi by 2 sine power mx into cos power nx dx is equals to integral 0 to pi by 2 sine power mx into cos power 1x dx. Because if n is odd, the last will be n comma 1. So this is sine power mx, if sin x is taken as t, sin x derivative is cos x, otherwise f of x whole power m into f dash x, f of x whole power m plus 1 by m plus 1. So this is sine power m plus 1x by m plus 1 from 0 to pi by 2. This is equals to, substitute the limit, sine power m plus 1, x is pi by 2, sine 90 is 1 whole power m plus 1, so 1 minus lower limit, sine power m plus 1 into 0, sine 0 is 0 by m plus 1 minus 0 by m plus 1, this is equals to 1 by m plus 1. So therefore Imn is equals to n minus 1 by m plus n into n minus 3 by m plus n minus 2, etc. So and so on. If I decrease this, two terms on the reducing the successive factor by 2 in the numerator as well as denominator, then the last term will be 1 by m plus 1. So if you are interested to know the previous term of this, it will be 2 by m plus 3. This is all if n is odd. So if n is even, we have discussed this case now earlier. Now if n is even, then Imn, so if n is even, it will be ended with I naught. That means Im comma n is equals to integral 0 to pi by 2 sine power mx into cos power nx dx is equals to 0 to pi by 2 sine power mx into cos power, since n is even, if n is even, it will be ended with I1, I0. If it is ended with n is odd, then it is I1, which we have discussed earlier case. I am not discussing this again to avoid confusion. So sine power mx cos power 1x 0x dx. So 0 to pi by 2 sine power mx into cos power 0, anything to the power of 0 is 1, into dx. Now sine power mx dx is, let us suppose this as x, sin x derivative cos x, otherwise okay. So this will be 0 to pi by 2 sine power mx dx. So at the beginning of our session we have discussed what is a integral 0 to pi by 2 sine power nx dx or integral 0 to pi by 2 cos power nx dx. Simply this is n minus 1 by m plus n minus 1 by n minus 3 by n minus 2, n minus 5 by n minus 4, etc. So if n is even, it will be, this is what we have discussed earlier. If you want the previous term also, I will write 3 by 4 into 1 by 2 into pi by 2. Okay. So now we have got here sine power mx dx. It won't be changed. If I write m here, then it will be simply how much? n minus 1 means m minus 1 by m. So this is m minus 3 by m minus 2, m minus 5 by m minus 4, and so on. So may I write this as this m minus 1 by m, m minus 3 by m minus 2, and m minus 5 by m minus 4, etc. 1 by 2 into pi by 2. That is, if the same case, if m is even, okay, and if it is odd, it will be m minus 1 by, if m is odd, m is even. So please, I am telling these things which we have discussed before yesterday's class. Integral 0 to pi by 2 sine power nx dx or integral cos power nx dx, n minus 1 by n, n minus 3 by n minus 2, n minus 5 by n minus 4, n etc. 3 by 4 into 1 by 2 into pi by 2 if n is even, and if it is odd, it will be n minus 1 by n, n minus 3 by, so earlier it is n, so if it is in terms of n, m, it will be m minus 3 by m minus 2, m minus 5 by m minus 4, etc. 2 by 3 into 1 if m is odd. So this is if m is even. I am telling you, this is nothing to do with what we are discussing now. These results we have discussed earlier yesterday. Integral 0 to pi by 2 sine power nx dx, that is equals to integral 0 to pi by 2 cos power nx dx. The results which we have discussed earlier. So in the place of m, simply I have substituted m, that's it. It won't be differed. So this is equals to m minus 1 by m into m minus 3 by m minus 2 into m minus 5 by m minus 4, etc. 2 by 3 into 1 if m is odd. Therefore Imn is equals to n minus 1 by m plus n, n minus 3 by m plus n minus 2, etc. m minus 1 by n, m minus 3 by m minus 2, m minus 5 by m minus 4, etc. 1 by 2 into pi by 2 if m is even and n is even. So that I will write later on. And the same is equals to m minus 1 by m, m minus 3 by m minus 2, m minus 5 by m minus 4, etc. 2 by 3 into 1 if m is odd and n is even case. Im comma n is equals to integral 0 to pi by 2 sine power mx into cos power nx dx. This is equals to n minus 1 by m plus n, n minus 3 by m plus n minus 2, etc. into, this is first part, and second, m minus 1 by m, m minus 3 by m minus 2, etc. So if m is even, it will be 1 by 2 into pi by 2. This is if m comma n are even. Next, this is equals to n minus 1 by m plus n into n minus 3 by m plus n minus 2, etc. into m minus 1 by m, m minus 3 by m minus 2, etc. 2 by 3 into 1 if m is odd and n is even. These two cases, in the case of n even, we are discussing. So if n is even and m is odd, so if you want the previous term, it will be 1 by m plus 2, 1 by m plus 2, etc. dot dot dot. Okay, so no need to remember this. If you want to remember this, then actually it will be end up with a confusion. Okay, all this we will be discussing in solving the problems. It will be very easier. Only thing is, if two cases I have discussed, what are they? Imn is equals to integral 0 to pi by 2 sine power mx into cos power nx dx is equals to n minus 1 by m plus n, n minus 3 by m plus n minus 2, etc. into 1 by m plus 1. If you want the previous term, it will be 2 by m plus 3 if n is odd, which is not equals to 1, and n minus 1 by m plus n into n minus 3 by m plus n minus 2, etc. into m minus 1 by m, m minus 3 by m minus 2, etc. into 1 by 2 into pi by 2 if n is odd is discussed. If n is even, comma, m is even. Since m is even, this part we have discussed yesterday, and the same is equals to n minus 1 by m plus n into n minus 3 by m plus n minus 2, etc. into m minus 1 by m into m minus 3 by m minus 2, etc. into 2 by 3 into 1 if n is even, m is odd. This we have discussed yesterday. So if you want to write the previous term of this, then it will be how much? We have discussed just now. This is 1 by m plus 2. 1 by m plus 2. My earnest request to you is not to remember these. Only thing is, for all of them, n minus 1 by m plus n, you need to remember. N minus 1 by m plus n. And the numerator is, and go on writing the numerator, with the successive factors reduced by 2. And so is the case with the denominator as well. And whenever we are getting 2 or 0 in the numerator, then actually we have to end up here into 1 by m plus 1 is what we need to write. So, and same n minus 1 by m plus n, you begin with this term, and the numerator, go on writing the numerator by successive factors reduced by 2, and so is the case with the denominator. And you proceed as long as the numerator either it becomes 1 or 2, you just have to stop. And the second part, you should start with m minus 1 by m, and this we have discussed yesterday itself. You just reduce the successive factor by 2 both on numerator as well as denominator, and in this process, if you got 1 by 2, the last term you write pi by 2, and the second part m minus 1 by m is common for this part also. And if you go on reducing the successive factors by 2, if 2 by 3 we are getting, then into 1, that is the final answer. So let us write all of them at one single place. Integral 0 to pi by 2 sin power mx into cos power nx dx is equals to 1 by m plus 1 if n is equals to 1. So this is equals to n minus 1 by m plus 1, m plus n, n minus 3 by m plus n minus 2, etc. into 1 by m plus 1. The previous term, if you want, then it is 2 by m plus 3. So if n is odd, not equals to 1, and this is equals to n minus 1 by m plus n into n minus 3 by m plus n minus 2, etc. into m minus 1 by m, m minus 3 by m minus 2, etc. 1 by 2 into pi by 2 if n is even, comma, m is also even. So if you want the previous term, it will be 1 by m plus 1, and this is n minus 1 by m plus n into n minus 3 by m plus n minus 2, and so on, etc. So this is, second part is m minus 1 by m, m minus 3 by m minus 2, etc. 2 by 3 into 1 if n is even, comma, m is odd, where m is not equals to 1, and the last one is 1 by n plus 1 if m equals to 1. If you want to know how this came, simply integral 0 to pi by 2 sin power mx, m means 1 here, so 1x into cos power nx dx this is equals to 0 to pi by 2. Cos derivative is minus sign. So cos power nx into minus sin x dx into minus. May I write this? Then because so cos x is f of x. Its f dash x is minus sin. So I want a minus here. Therefore minus of minus I did. Now f of x whole power n into f dash x dx is f of x whole power n plus 1 by n plus 1 result. Otherwise, if you do not know this, then simply cos x equals to t you take. Then minus sin x dx equals to dt. And then if you proceed, we will be getting cos power n plus 1x by n plus 1 from 0 to pi by 2. Now since the process is over, so minus 1 by n plus 1 into cos x is pi by 2, cos 90 is 0 power n plus 1 is 0 minus cos x is 0, cos 0 is 1 power n plus 1 is 1. So minus of minus is 1 by n plus 1. So therefore these 5 formulae we get. So first and last you no need to remember. As far as the middle 3 are concerned, actually first n minus 1 by n plus 1 is common among all the things, and this can be discussed in two ways. If n is even, if n is odd, that's it. If n is odd, then n minus 1 by n plus n is the very first thing to remember, and we need to reduce the successive factors by 2 on both the numerator as well as denominator until the numerator gets either 2 or 1. And the next, if the further reduction is not possible, then 1 by n plus 1 is what we have to write if n is odd. So if n is even, there will be two cases arised. If m is even and m is odd. If n is even, again two cases arise. M is even and m is odd. So for that also actually first thing is n minus 1 by n plus n is what we need to remember, and you go on reduce the successive factors by 2 both on numerator as well as denominator, and the second part until we reach either 2 or 1, and later on the next part is m minus 1 by m. This we have discussed yesterday. Integral 0 to pi by 2 cos power nx dx, n minus 1 by n minus 3 by n minus 2 etc. If it is even, 1 by 2 into pi by 2. Therefore in n is even, if m is even, 1 by 2 into pi by 2 is what we are getting. If m is odd, the same thing, n minus 1 by m, the second part, n minus 3 by n minus 2 etc. 2 by 3 into 1. So the whole thing is revolving around these 3 things only, which we will be discussing in the solving exercise. Now let us discuss exercise 7c. So the first 2 problems are integral 0 to pi by 2 sin power 10x dx, integral 0 to pi by 2 cos power 11x dx. So we have a formula. What is that? Integral 0 to pi by 2 sin power nx dx, integral 0 to pi by 2 cos power nx dx. So for both of them it will be n minus 1 by n minus 3 by n minus 2 etc. into 1 by 2 into pi by 2 if n is even, and the same n minus 1 by n into n minus 3 by n minus 2 etc. into 2 by 3 into 1 if n is odd. Okay, so if you try to solve the first problem here, this is even number. Even number means we have to use this. So n is equals to 10 is even, that is equals to the first term is n minus 1 by n. What is n here? 10. 10 minus 1. 10 minus 1 by 10. How much? 10 minus 1 is 9 by 10. So just remembering the very first term is enough. So from now on we have to reduce by 2 both on the numerator as well as denominator. So 9 by 10. So you reduce by 2, it is 7. Reduce by 2 here, 8. Next it is 5 by 6. Further reduction gives 3 by 4. Further reduction gives 1 by 2. If we got 1 by 2, what is the next term, immediate term? Pi by 2. So that is okay. All you need to do is just to solve it. Okay, that's it. And this is 5 2s are 10, and that's it. So 9 7s are 63. 3 2s are 6. So 9 7s are 63. Pi by 2 2s are 4. 4 2s are 8. 8 4s are 32. 32 2s 64. 64 8s 512. So this is the answer for the first question. And if you come to here, it will be, see here, n equals to 11, which is odd. So we have to prefer this one. N minus 1 is how much? 11 minus 1. 10 by n is 11. So just writing the very first term is sufficient. From here on, we have to as well as denominator. So here 10 minus 2, 8 by 11 minus 2, 9. Next 6 by 7. Next 4 by 5. 2 by 3. If 2 by 3, so into 1 is the last answer. So here 3 2s are 6. Okay. So next 5 2s are 10. And that's it. 2 2s are 4. 4 4s are 16. 16 8. So 16 into 8 by 11 into 9 into 7 into 2. This is equals to 256 by 693. The next question is integral 0 to pi by 2 cos power 7x into sin square x dx. So here sin power is always treated to be m and cos power is always treated to be n. So here m is equals to 2, n equals to 7. So if n is odd, then integral 0 to pi by 2 sin power mx into cos power nx dx is equals to n minus 1 by m plus n minus 3 by m plus n minus 2 etc. into 1 by m plus 1. So if you want to write its previous term, it is 2 by m plus 3. So this is the formula we have. This is the reduction formula we have when n is odd. Now all you need to do is a substitution, right? So n equals to 7 minus 1 6 by n plus n 2 plus 7 9. Next further reduction by 2 is 4 by 7. Further reduction 2 by 5. So can we proceed any further reducing by 2? No, because 2 minus 2 is 0. And check here, 2 by m plus 3 is 2 by m is how much? 2. So 2 plus 3 is 5. So this term we got. So what is the next immediate term for this? 1 by m plus 1. What is m plus 1? 2 plus 1, which is 3. So 3 2s are 6 and 2 4s are 16 by 9 7s are 63, 63 5s 315. The next question is 0 to pi by 2 sin power 4x into cos power 4x dx. So here m is equals to n is equals to 4, both are even. So if both are even, we have a formula, integral if m comma n are even, integral 0 to pi by 2 sin power mx into cos power nx dx is equals to n minus 1 by m plus n minus 3 by m plus n minus 2 etc. into so the m minus 1 by m minus 3 by m minus 2 etc. 1 by 2 into pi by 2, because here m is even. Integral 0 to pi by 2 sin power nx dx is this we know. So the same thing. And if you want to write the previous term of this, it will be how much? 1 by m plus 1. I told you many times that actually this term we need not remember. Only thing is n minus 1 by m plus n is what we need to remember, and the both numerator and denominators are reduced by 2 until we reach to either 2, and if further successive reduction by 2 is not possible, then the second part m minus 1 by m is what we need to begin with, and then we have to reduce by 2 both on numerator as well as denominator. And if m is even, so 1 by 2 into pi by 2. So this we have known. So this is equals to, substitute. N is 4. 4 minus 1 is 3 by 4 plus 4, 8. So further reduction is possible, of course. So 3 minus 2, 1 by 8 minus 2, 6. Now you stop here. Further reduction is possible or not, you see. 1 minus 2 is minus 1. Therefore, this first part is over. And the second part we have to start. What is n? 4 minus 1. 4 minus 1, 3 by 4. And further reduction is possible, of course. 3 minus 2, 1. 4 minus 2, 2. If 1 by 2 we got, into pi by 2 is what we have to write. And see this first part's previous term is 1 by m plus 1, which I have been telling you not to remember to avoid any confusion. And if you check here, 1 by m plus 1 is what? 1 by m is 1 by m plus 2. So see this 3 by 4. 3 by 4's previous term is what? 1 by m plus 2. You need not remember. So here see this. What is 6? M plus 2. So 4 plus 2, that is this term. Okay. So if you solve this, so 3 2s are 6. Okay. And here 3 into pi, 3 pi. 8 2s are. So 8 2s are 16, 16 4s are 64 2s, 128 2s, 256. So the next question, integral 0 to pi sin cube x into cos power 6x dx. If you see, this is not integral 0 to pi by 2. The reduction formula is only applicable for integral 0 to pi by 2 sine power mx into cos power nx dx. Therefore, we need to convert that integral 0 to pi into integral 0 to pi by 2 first. So how do we do this? So this I will take it as f of x. So we have a property integral 0 to a f of x dx is equals to 2 integral 0 to a by 2 f of x dx if f of upper limit minus x, f of a minus x equals to f of x, and the same is equals to 0 if f of a minus x equals to minus f of x. If you are not familiar with these properties, I recommend you to watch the very first video of definite integrals, part 1, where I have discussed all these properties. Now, let f of x is equals to sine cube x into cos power 6x. Now f of what this property says, upper limit minus x. So here upper limit is pi, so pi minus x. Let us see we will be getting f of x or not. So if f of x we will get, then actually the 0 to a is converted into 2 will come forward, and this a, it will be half of this a. So sine cube pi minus x into cos power 6 pi minus x. So this is equals to sine 180 minus x is sine x, whole cube is sine cube x, into cos 180 minus x is minus cos x whole power 6. So that is cos power 6x dx. Yes, f of pi minus x equals to f of x we get. Therefore, integral 0 to pi sine cube x into cos power 6x dx can be written as 2 integral 0 to pi by 2 sine cube x into cos power 6x dx. So if n is even, comma m is odd, then integral 0 to pi by 2 sine power mx into cos power nx dx is equals to n minus 1 by m plus n, n minus 3 by m plus n minus 2, etc. into m minus 1 by m, m minus 3 by m minus 2. Since m is odd here, etc. 2 by 3 into 1. So if you are interested to know the previous term of this, then it will be 1 by m plus 2. So I have been telling you not to remember this. Automatically we will get it in solving the problem. So let us see. 2 into n minus 1, n is 6, 6 minus 1 is 5 by 3 plus 6 is 9. Further reduction by 2 is possible or not? Of course. So here 3 by 7. Further reduction is possible? Of course, 1 by 5. So further reduction is possible? No, because actually 1 minus 2 is minus 1. Therefore we have to end up. So, and you check this with this 1 by m plus 2. What is m here? 3. 3 plus 2 is 5. So that's what I am telling you. Not to remember this, we will be getting this automatically while solving the problem into the second part is m minus 1. What is m? 3. 3 minus 1 is 2 by 3. If it is 2 by 3 into 1 is the final answer. Now this 3 gets cancelled and 5 gets cancelled. So we are left with 2 2s are 4 by 9 7s are 63. So let us discuss the sixth question. As usual, like the last problem, it is also not in the form of integral 0 to pi by 2. So we need to convert this into integral 0 to pi by 2 first. So how? By suitable properties that we have discussed in definite integrals part 1. So let f of x is equals to sin square x into cos power 4x. So we have a property that integral 0 to 2a, it is of the form 2a, f of x dx is equals to 2 integral 0 to a f of x dx if f of 2a minus x is equals to f of x, and the same is equals to 0 if f of 2a minus x is equals to minus f of x. So let us first do this. What is f of x is this? F of 2 pi minus x is equals to sin square 2 pi minus x into cos power 4 2 pi minus x. So sin 360 minus 6x, so that is lying in the fourth quadrant, minus sin x whole square, it is sin square x, into cos 2 pi minus x, cos 360 minus x is cos x whole power 4 is cos power 4x. Therefore we get f of x, f of 2 pi minus x is equals to f of x. Therefore integral 0 to 2 pi sin square x into cos power 4x dx is equals to, since 0 to 2a f of x dx, f of 2a minus x equals to f of x is being followed, this 0 to 2a f of x can be written as 2 integral 0 to. So that means 2 integral 0 to half of this 2 pi. 2a is there, a we get. So 2 pi, half of that. So pi into sin square x into cos power 4x dx. Still it is not converted into 0 to pi by 2. Therefore further conversion, so further reduction is possible. So this is, let again f of x I will take here. So what is f of pi minus x? So sin square pi minus x. I am not dragging this question because same. So integral 0 to a f of x dx is 2 integral 0 to a by 2 f of x dx if f of a minus x is equals to f of x. That's what I am doing here. Sin square pi minus x into cos power 4 into pi minus x. So sin 180 minus x is sin x whole square is sin square x into cos 180 minus x is minus cos x whole power 4 is cos power 4x. Therefore this is f of x. Hence this is equals to 0 to 2 pi sin square x into cos power 4x dx is equals to 2 into integral 0 to pi, it is followed, that's why it will be 2 integral 0 to pi by 2 sin square x into cos power 4x dx. Okay, so this is 4 into, here both m comma n are even. If m comma n are even, then what is this formula? Integral 0 to pi by 2 sin power mx into cos power nx dx is equals to n minus 1 by m plus n minus 3 by m plus n minus 2, etc. So, and the second is m minus 1 part is m minus 1 into m minus 3 by m minus 2. Since m is even here, etc. into 1 by 2 into pi by 2. So, if you want to know the previous term of this, what is the previous term? It will be 1 by m plus 2. All you need to do is to substitute in this. So, this is 2 2s are 4 into n minus 1. N is 4. So, 4 minus 1 is 3 by 2 plus 4 is 6. Further reduction is possible. 1 by 4. So, you may check with this. M plus 2 no. M is 2. 2 plus 2 4. So, we get this. What is the next term of this? The second part of this is to be continued. What is m? 2. 2 minus 1 is 1 by m is 2 into pi by 2. That is equals to, so 4 gets cancelled. So 3 is cancelled 2 times. So pi by 2 2s are 4, 4 2s are 8.